So welcome to this video where we'll be going over June 2022 mechanics. Let's go. So first question, we've been given that the velocity is this vector here. It's 3t squared I minus 6t to the power half j. We need to find the speed of p at time t when t is 2 seconds. So this one is fairly simple. But to find the speed, so we'll be given the vector, right? So what we need to do is once we substitute 2 in for t, then we need to work out the length of that. So first thing first, let's substitute in 2 for t. So if we do that, we get a 3, then a 2 squared, and we'll have the I still, minus 6. And then this will be 2 to the power half, so let's write that as a root 2. And that will all be, let's just do j for now. And then, so this will be a 3 times 2 squared, so 3 times 4, so that'll give me a 12i minus a 6 root 2 j. And then let's find the speed, so we just need to do 12 squared plus 6 root 2 squared. Obviously, you can do a minus 6 root 2 squared, but it doesn't make a difference. And then that is all square rooted. Okay, and if you work that out, you would get a what do you get? You get a square root of 144. A 6 root 2 squared, that would be a 36 times a 2, so a 72. Okay, so we have the square root of 144 plus 72, which is 216. 216. And now we have the square root of 216. Well, think of the highest square number factor. Now for this one, I know that 216, that's like 6 cubed, okay? So I know that 6 times 6 times 6. So I know that it's going to be a root 36 root 6. So therefore, that is a 6 root 6. And it's speed, so you can write meters per second, okay? So part B, we need to find the, in terms of I and j, we need to find the acceleration of p at time t seconds. So acceleration, if we've been given the velocity, which is here, look at the acceleration. When we're given stuff like this, all we need to do is just differentiate that. Because differentiating that, getting dv over dt, that will give us the acceleration. So if we differentiate that, so we differentiate the 3t squared. If I rewrite that down here, we have v is equal to a 3t squared I. And then we have minus a 6t to the half j, okay? So if we differentiate this, that will be a dv over dt, and that would be a 6ti, minus a 6 times half is a 3t, and that'll be a minus a half j, okay? And then that would be b done. And for question C, we need to find the position vector of p at time t is equal to 1 second. So for part C, we're told that time t is equal to 4 seconds. The position vector of p is I minus 4j meters. We need to find the position vector of p at time t is equal to 1 second. So again, for this question, if we've been given v here, okay, we know v is this. To work out the position vector now the position vector, that is, we're talking about like the length now, right? Like where it is, the position vector in terms of the origin, right? So in this case, we're thinking about the distance, right? Therefore, instead of differentiating, now we're just going to integrate the velocity, and that will give us the equation we need. So if we're to integrate that, okay, if I write that here, this is C, then is S would be integrating the V with respect to T. So therefore, to work out S, it would be the interval of 3t squared I minus the 6t a half j, okay? And this is with respect to t. So if we integrate this, we would get if we integrate the 3t squared, we would get a t cubed. Then we'll just have the I here. And if we integrate this one, we would get a 6 t, and then 3 over 2. And then if we have the j here, and then we're going to divide by that 3 over 2 again. Okay, which leaves us with a t cubed I and then that would be a minus 4t to the power 3 over 2j. And then don't forget that we are integrating, so we're going to have a plus c. So now we have that s is equal to t to the power 3i minus 4t to the power 3 over 2j plus c. They tell us in the question that when t is 4 seconds, the position vector is I minus 4j. So we can use that information now to work out our constant value, to work out our c. So if we do that now, well, we know that in this case, when we have s is I minus 4j, okay, we know that t is going to be 4, okay? So therefore, we'd have a 4 cubed, okay, 4 cubed I minus a 4 times 4 to the 3 over 2, okay, and that's all of that is going to be j, okay? And that will give us our plus c value, okay? So if we work this out, we get an I minus a 4j, that's equal to a 64i. And then for this one, we have so the 4 to the power of 3 over 2, that'll give us a 2 to the power of 3, which is an 8. So 4 times an 8, that'll give us a minus 32j. And then we have the plus c. And now we just need to rearrange this. So if we we get I minus 64i, so that'll be a minus 63i. And then we bring the 32 over, so that'll be a plus 28j, and that is equal to c. So now we've worked out our c value. So now if we rewrite this whole equation now, that would be s is equal to a t cubed I minus 4t to the power of 3 over 2j. And now our c value, that'll be a minus 63i plus 28j. And now let's just rearrange this so we can get all i's together and all j's together. So that's an s is equal to a t cubed minus 63i, and then we would have a 28 minus a 4, bigger, minus a 4t to the 3 over 2j. Okay, so now that we've done that, in the question, they want us to work out the position vector of p at time t is equal to 1 second. So therefore, now we can just substitute in t for 1 for t, and that will give us our answer. So if we do that, we get s is equal to a 1 cubed minus 63 is a minus 62i, and then a 28 minus a 4 times a 1 to the power 3 over 2, that's a minus 4 times a 1 there, so it's 28 minus a 4, so that'll give me a plus 24j, and that'll be our answer. The position vector would be minus 62i plus 24j. Okay, so for question 2, this is a forced question. So what I'm going to do is, first thing first, I'm going to draw my diagram. So I've started to draw it now. Now what I've done is, we've got the horizontal force here of x newtons. I've just drawn it on the other side. I think it's a bit more easier if I feel like if you draw the forces more outwards than inwards. And I've also drawn the angle alpha as well. So just keeping it the same. And now I'm going to add everything else we've been given in the question. I'm going to go through line by line. So first things first, we're told that a rough plane is inclined to a horizontal and angle alpha, where tan alpha is 3 over 4. So if you know tan alpha is 3 over 4, then if I do a little right angle triangle here, okay, therefore, if tan alpha is 3 over 4, that means that the opposite over adjacent is 3 over 4. So the opposite is 3, the adjacent is 4. If we do Pythagoras theorem, that means that the hypotenuse would be 5. So therefore, we know that sine alpha would be opposite over hypotenuse. So sine alpha would equal 3 over 5, and cos alpha would be 4 over 5. Okay. And to the second line, we're told that a small block B, so B is just that block B here. Okay, we are told that a small block B of mass 5 kilograms. So it's got a mass 5 kilograms. So if I just draw a downwards weight now, so this is going to be of 5g newtons. Okay, it's held in equilibrium by a horizontal force of x newtons, which we've already included. We also are told that the magnitude of the normal reaction of the plane is 68.6. So if it's normal reaction to the plane it's going to be perpendicular to the plane. So it's going to be here. That is 68.6 newtons. So one last thing we need to add. Well, we know there's going to be friction because we have a rough plane here. Now, to work out the direction of the friction, well, we have two possibilities, okay? We can either consider that the friction is going to be going in this direction or this direction. Now, it could be in either one because it's in equilibrium. We don't really know the force of x yet, so it could be going in either direction. But actually, it doesn't really matter what way we put the friction. Because if we want to work out the friction, because part A is working out the friction, if we make the friction, we can make the friction in any direction. So I'm going to make the friction in this direction here, okay? I'll make the friction going down the plane. But it doesn't actually matter what way we do the friction, because in this case, if I were to do the friction and my friction became a negative number, then we know the friction would act in the opposite direction. If I were to do the friction upwards and we get a negative number, we know that it's going to be acting in the downwards direction. And if we get a positive number, then the friction acts in that same direction that we have drawn it in. So actually, it doesn't matter if you put your friction downwards or upwards, because depending on if your answer is positive or negative, you'll know the direction of the actual motion. So in this case, I'm going to consider it downwards. And the first question is, we define the magnitude of the frictional force acting on B, and then state direction of the frictional force. So first of all, let's work out the magnitude. Okay, so let's think about working that out. We need to resolve some forces. So there's two forces we want to consider, okay? We want to consider the first things, what we're going to consider is we're going to consider forces in that going up the plane direction. So I guess you can think of it as the northeast direction. That's what we're going to think of first. So we have three forces acting in that direction. So we have the X, the F, and the 5G. So if I zoom in here, well, we need to figure out what this angle is here. Okay, that will help us know at the angle for its X newtons is in that direction. So first things first, let's work out this angle here. We know this angle, because it's a right angle triangle here, we know that alpha and that this angle here must add up to, must give us that 90, which we want, the 90 degrees. So we know this is going to be a sine alpha, okay? So this is a sine alpha here. And there's loads of ways you can think about it, but I am going to draw, let's see, a dotted line here, okay? And then by doing that, I know that this is going to be a cos alpha, okay? And then I know that this is going to be a sine alpha, therefore this is going to be a cos alpha, okay? I'm just using the fact that in 90 degrees, we know that we're going to get a sine alpha plus a cos alpha. So I'm just using that, and I'm just pretty much drawing 90 degrees. And now by doing that, I know that for that X, it's going to be an angle of the cos alpha in that northeast direction, okay? So, okay, we've worked out that. So if we want to resolve, then we know that in that direction, what will we be? Well, we know it's an equilibrium. So we know that it's going to be X cos alpha, okay? And that would equal, because we're in equilibrium, we don't have to worry about MA. Then look at those, now look at the forces going in the opposite direction. Well, we have the F, so we'll just get F here. And then that 5G, that weight, that is going, and that 5G is in the angle of sine alpha, okay? So an angle of sine alpha. So therefore it would be F plus 5G sine alpha, okay? And we can work out some of these values. We know cos alpha is 4 over 5, so we know that it's going to be a 4 over 5x, and that's equal to an F. Now 5G times 4 over 5, that will give us just a 3G. Okay, and for now, we can leave it as that. That's all we can do with that. So we know that resolving in that direction, we get a 4 over 5x is equal to an F plus a 3G, okay? So now let's look at resolving in this direction here. Let's look at resolving in this direction, the northwest direction, okay? So this is where we have the normal reaction. In this plane, we also have three forces. So if we start with the normal reaction, okay, that would be a 68.6. And that would equal, well, we have X also in that direction. that is an angle of the sine alpha, so it'll be x sine alpha. Okay, we just need to look at what we've done here. So if we want it in that direction, it's just an angle of sine alpha here, so that x. And then for the 5g, well, that would be getting that same direction. It would be an angle of that cos alpha. So therefore, we would also get a plus 5g cos alpha. And now we can just actually work out what our x value is now. So that would be a 68.6. That is equal to sine alpha is 3/5, so it'll be a 3/5x. And a 5g cos alpha, if we leave that in g's just for now, what would that be? That would be a 4g, okay? So that'd be 68.6 is equal to 3/5x plus 4g. And now we can just work out what our x value is. If you want to use your calculator, okay, you can do 68.6 minus 4g. We know g is 9.8. So 68.6 minus 4 times 9.8. And then once you get that, just divide by the 3/5. Okay. And then if you do that, you'll get x as 49 newtons. Okay. So again, just do 68.6, take away 4g, we can work that value out, and then we just divide by the 3/5, we get x is 49 newtons. So now that we know x is 49 newtons, we can just substitute that value back in now to work out our f value, and if we do that, we get a, so we'll substitute it back into this one here, and if we do that, we get a 4/5 times 49, okay, that's what our x is, and then that is f plus 3g. I'm just gonna write the value of 3g now, so that is a 29.4, and then we have 4/5 times 49, so that is 0.8 times 49, which is a 39.2, and that's equal to f plus 29.4. Therefore, our f value is just going to be 39.2, take away 29.4, and if you work that out, you get a 9.8 newtons. Okay, so we worked out f is 9.8 newtons, and then for that part 2 now, part A, we need to state the direction of the frictional force acting on B. Well, we've already done, well, we can just look at that, because our f value is a positive value, okay, and we've considered that the friction is in the downwards direction, it's going down the slope. Well, then if we want to look at direction would just be acting down the slope. Okay, so you can say that the force for direction, all you can say is the force is just acting down the plane. Down. You can say that it's just acting down the plane. Okay, there's not more you need to say that. For this part, you can just write that the force is acting down the plane, and we know that because our answer for f is positive. Okay, our answer for f is positive, and we've considered that it's already going down the plane, so the force just acting down the plane is fine. Okay, so for part B, okay, now we have that the horizontal force of the magnitude x newton is removed, and B now moves down the plane. We're told that the coefficient of the friction between B and the plane is 0.5. We need to find the acceleration of B down the plane. Okay, so I'm going to draw another diagram now with the information which I've been given. Okay, so what do we know about this question? Well, we have no magnitude x newtons. We will still have a normal reaction. Now, the normal reaction, I'll just write that as R. Okay, so you know the normal reaction is R. Due to the fact that we've lost that horizontal magnitude, R, it could change, so we just don't know what it is. We're told that we're moving down the plane, so what I can do here is I'm going to write just this, then this is my acceleration, so we're now moving down the plane. Now this question, because we're moving down the plane, we still have a rough plane, therefore friction is going to be in the opposing direction of motion. Okay, the opposing direction of motion. Therefore, our friction must be happening in this direction. So right now, because we're moving down the plane and we're on a rough plane, our friction has changed. It's now going to be in the opposite direction to what it was in the previous question, because Remember, friction always opposes the direction of motion. So if we're now moving down the plane, friction must be acting up the slope. And now using this, well, now we need to work out what the acceleration is using what we've given. So how do we do that? Well, again, let's just resolve some forces. So let's start going down the plane. Okay, so for this one, because we have acceleration, okay, we have motion, this time it will be F is equal to ma. So it will be the resolving forces, and then that will equal ma. So in this case, if we think about it, we know that this is going to be a sine alpha, okay? So therefore, if we think about going down the plane, we're going to have a 5g sine alpha, okay? Now it's going to be a minus that the force going up the slope. In this case, that is F, okay? And that is equal to ma. Well, we know the mass is 5 kilograms, so mass is just 5, and then a, an unknown. That's what we want to work out. We want to work out a value. Now, if we put in the value for sine alpha, we get a 5g times by a 3 over 5. So that would just be a 3g minus f is equal to 5a. And that's all we can do with that for now. So let's just leave that alone. Okay, now we're going to resolve in the same direction as the normal reaction. Okay, so the normal reaction, we don't have any motion in that direction. It's perpendicular to the direction of motion. Therefore, we can treat it like it's an equilibrium in that direction. So therefore, we have R. And what would that equal? Well, we do have an opposing force. It'll be this 5G. So this 5G now, we'll zoom in a bit. If we think about it, okay, and we do my dotted line here, well, this 5G will also have a direction in that, and then that will be cos, because we have sine in the other way, so this one will just be a cos, okay? So therefore, this will just be R is equal to a 5g cos alpha, okay? And therefore, well, we can work that out, because 5g cos alpha, we know cos alpha is 405, so 5g times a 405 is just simply going to be a 4g. So we know that R is equal to 4g, okay? And if we know R is equal to 4g, we're also told in the question that the coefficient of friction is 0.5. So therefore, what do we know? Well, if we think about the equation quickly, the equation for friction is mu r. So that's coefficient of friction times normal reaction. So therefore, for the friction, that would be a 0.5 times a 4g. So we know that the friction is going to be a 2g. And for the friction is going to be a 2g. Well, now we can substitute that into this equation here now, and we can work out our acceleration. So what would that be? We substitute that in, what do we get? We get a 3g minus f, which we now know is 2g. So 3g minus 2g is equal to a 5a. And then that means that g is equal to a 5a. So a is just equal to g over 5. And then if you work out what g over 5 is, that's a 9.8 divided by 5 on your calculator. You would get exactly 1.96 meters per second per second. Okay, for this question, we have two forces, F1 and F2. We also have a particle mass of m4g is at rest at the point A. And then we need to show that so these forces are both applied to P, and given that P moves in direction of the vector 3i plus j, we show that lambda minus 3 mu plus 7 is equal to 0. Okay, so first things first, we have that we know F1 is 4i minus j, so, and we know F2 is the lambda I plus mu j, and we know it moves in the direction of 3i plus j. So if I write this in column form, if I take F1 first, that would be a 4 minus 1 in column form. That represents the 4i minus the j. And F2, that would be the lambda plus the mu. Okay, and because both of these are applied to P, we just need to look at the sum of them. Okay, and we know the sum of them, well, that would just be in the direction of the vector 3i plus j. Therefore, it would have some scalar in that direction. So let's say that it's scalar k of 3, that's a 3i plus a j, so that's a 1. So we know that, okay, we know that if we were to put these forces together, it must be in the form of this, where we have some scalar of 3, 1. And therefore, now we can work this out. So that would be 4 plus lambda and minus 1 plus mu, okay, that would equal a k times 3, so 3k, then a k times 1k. Okay, and now, as you can see, we're going to have simultaneous equations, okay? So we're going to have the 4 plus lambda is equal to 3k, and the minus 1 plus mu is equal to k. If I call this 1 and this is equation 2, therefore with equation 2, let's just multiply everything by 3. So therefore we get a minus 3 plus 3 mu plus 3k. And then what we can do is we can just do equation 1 minus equation 2. And if we do that now, we'll get a 4 minus a minus 3. So that's a 4 plus a 3. So we get a 7. Then we get the lambda minus the 3 mu. Okay, so we can't do anything with that. So just be a lambda minus a 3 mu. And then the 3k plus 3k, they cancel out. So that's just a 0 there. And you can see it's pretty much in the form they want. We just need to rearrange it around. And then we get it in the form of lambda minus 3 mu plus 7 is equal to 0. So for part B now, we're told that at time t is equal to 4 seconds, we're told that p passes through the point P. And given that lambda is 2, we need to find the length of AB. Okay, so they tell us that lambda is 2, and they also tell us that at t is equal to 4 seconds, p passes through the point B. So with all this information, what we can do is we can actually work out our mu value now. We already know our lambda value is 2. We can work out our mu value, and then we have all the values for f1 and f2. And then once we do that, we can work out the acceleration. And by working at acceleration, similar to question 1, we can then just integrate twice. Because if you integrate once, it will give us our velocity. Integrate again will give us our distance. And then we can use that to work out the length. So first things first, let's work out our mu value, okay? So they tell us that lambda is equal to 2. Therefore, if we work out our mu value here, then that would be a 2 minus 3 mu plus 7 is equal to 0. Therefore, we would get a 9 minus 3 mu is equal to 0. So a 9 is equal to a 3 mu. Therefore, mu is equal to a 3. Okay, so we know mu is equal to 3. Therefore, for F2, we know F2, that would be, that's what lambda I plus mu. So therefore, we know that's going to be a 2i plus a 3j. Okay, so now that we have the F1 and F2, okay, we know that their F is equal to ma. Now we can actually work out the acceleration now. So let's work out the acceleration. So we know that both of these are applied to P. So remember, because both of these are applied to P, we want the sum of the forces, okay, because they're applied to P. So therefore, we need to work out the sum. So obviously that's just so if we write this in, let's write this. So if we look at the sum, that would just be a 4i plus 2i. So that would just be a 6i. Then a minus j plus a 3j is just going to be a 2j. Okay, so we know the sum of the forces is 6i plus 2j newtons. Therefore, if we do F is equal to ma, we know that it's going to be a 6i plus 2j is equal to mass times acceleration. That'll be a 4a, okay? Because in the question, they tell us that the mass is 4 kilograms. And now, pretty simple, we can work out the acceleration just divided by 4. Therefore, we get a is equal to a 1.5i. And then j, that's 2 divided by 4, so that'll be a 0.5j. So now we know acceleration is this. Now, how do we work out the distance? So to work out the distance, well, what do we know? Well, it's like in the previous question 1. We know that if we have something like this, what we can do is a is the same as dv over dt, okay? It's the same. So really, we have 1.5i plus 0.5j. That is the same as dv over dt. And we can just integrate this twice, because if you integrate it once, you get the velocity. And if you integrate the velocity, you will get the displacement, okay? So that's what we're going to do. So we're going to integrate with respect to t. Now, we don't have any t's at the moment, though. So if we have no t's, then what do we do? Well, fairly simple what we need to do. we just need to add t's, okay? If we're integrating with respect to t and we have no t's, we just have constants, then we need to add the t's. So we know that v is going to be a 1.5t, and that's going to be I, okay? And that is plus a 0.5t, and that will be j. And now if we integrate this again, because remember that the displacement is the integral of v with respect to dt. So we're just going to integrate that again now. So we integrate this now, that'll give us our s value. So we just need to integrate 1.5 ti plus 0.5 tj. Okay, so let's integrate this now. So with respect to t, and if we integrate this, we get a 1.5 t squared over a 2, and that's an I. Then we get a 0.5 t squared over a 2, and that's a j. And if you work that out, you would get a 3 over 4 t squared I, okay? And for the next one, you would get a 1 over 4 t squared j, okay? So now that is our s value. Now, they tell us that at time t is equal to 4 seconds here, so therefore, to work out our s value, we just need to put in 4 for t. So that'll be a 3 over 4, 4 squared, so I, plus 1 over 4, 4 squared, that's j. Therefore, if we work that out, you get a 3 over 4 times 4 squared, that's a 6, 3 over 4 times 16. So 3 over 4 times 16, that's a 48 over 4, that would be a 12i. And then you have a 1 over 4 times 4 squared, that's 1 over 4 times 16, that's 16 over 4, that'll give us a 4j. So now s in vector form is 12i plus 4j. It wants the distance, therefore the distance, so just need to do 12 squared plus 4 squared, all square rooted. You get the square root of 144 plus 16, okay? And then that gives us the square root of 160. And then if you think about that, if we write that in the third form here, then that would be a root 16 root 10, and that cancels down to a 4 root 10, okay? For this question 4, we have a uniform rod AB, and it has mass m and length 2a. So let's do the mass first. So we know the mass is uniform, so the mass is going to be in the center of that rod. So if I draw the mass would be like here, okay? And that has a mass of m, so that will be mg newtons. We know it's length 2a. I'll look at the length later. We have another particle of mass 2m that's attached to the rod at C. So we have C here. So there would be another mass there, and that would be 2mg newtons. Okay. Well, so we're told that we are on rough horizontal ground. Okay, we're on rough horizontal ground. Therefore, we're going to have normal reaction as well to the ground. That would always be there. Let's call that R newtons. Okay, so that's R newtons. And we also know that because it's rough horizontal ground, we have friction. Now, before we put the friction on, what else do they tell us? They also tell us that we have a light string which is attached at the end of B on the rod, okay? So it just says light string. Now, because it says light string, doesn't say light and extensive or anything like that. It just says light string, which means that we're going to have tension. So we're going to have tension here, and that can be called T newtons. Okay, that's very key. It just says a light string. So we're going to have T newtons there. And as for our friction, well, for our friction, there's two ways it can go. Okay, so we know there's going to be friction on the ground at A. So either the friction is going to go in this direction here, so it'll go either here, or it'll go in this direction, so it'll go here. Now we need to figure out which direction the friction is going in. Well, if you think about it, in this diagram we have here, we only really have one horizontal force, like one horizontal component of force, okay? And that would be the T newtons. because the T newtons is the only force. If I just draw like a dotted line here, right? This is a horizontal line. Then that T newtons will have a horizontal component. It's the only force which can have a horizontal component, okay? The R newtons and both the weights, they will just have vertical components. They won't have any horizontal, which means that if we have friction, we need friction, because we're in equilibrium, we need friction to balance out that force. Hence, our friction will go towards the right, okay? So friction is there, and that would be F newtons, okay? So that is just all because we need to have another horizontal component balancing that T newtons force. And funny enough, the first question is explain why the frictional force on the rod acts horizontally to the right of the diagram. Well, as I just stated before, the reason why it acts right is because we need a force which balances out that T newtons, okay? Because that T newtons at the moment, that would be the only horizontal force. So therefore, the frictional force must be going towards the right to balance out that T newtons to keep it in equilibrium, okay? So saying something like that, that will be part A. And for part B, we need to show that the tension in the string, we show that T is 2mg cos theta, okay? So let's work that out. Okay, so I've just redrawn the diagram. And now let's put in all the information we know, okay? So what do we know? Well, we know that we are going to have this angle here would be a sine theta. I'm just going to put that in. And we also told the lengths as well. So we know that the whole of the length of the uniform rod is 2a. What do we know? We know that this distance here, okay, we know that this distance, that would just be a because it's uniform, right? So it's going to be in the center of that rod. Okay, and let me just label that this is a and this is b. So we know that's going to be a. Okay, and in the question, they tell us that AC is 1.5a. So if AC is 1.5a, we also know that this distance here must be a half a, right? 0.5a. And therefore, we also know that this distance, therefore, because the whole of the length is 2a, this also must be a half a. So now that we've worked that out, now when they give us questions like this, where they give us the length of something, usually that means that we're going to have to take moments, okay? Now, if you're ever unsure about when to take moments, then what you should think of is if you try and resolve the forces normally, like let's say we try and resolve vertically, for example, what will end up happening is we'll just end up having too many unknowns, right? We don't want too many unknowns. For example, if we were to resolve vertically right now, we'd have the t and then either cos or sine theta plus r, and that would equal the 3mg. But we have two unknowns there. That doesn't help us figure out what t is. So that's a clue that if you have too many unknowns, it's always best to take moments at a certain point where you can eliminate as many unknowns as possible. So in this case, we want to take moments. And the best place to take moments is at A, because we have the R newtons and we have the frictional force there. We don't know what those are. Those are unknowns. So if we take moments at A, we will eliminate both those forces, and then we'll just be left with T as an unknown. So let's take moments at A. If we take moments at A, then that T would have that T newtons, okay? So that T, that's already perpendicular to the rod. There's a right angle there. Therefore, we don't need to adjust that. That will just be T. And then we need to times it now by the distance to A. That would be 2A, so T times 2A, okay? And that would be our anti-clockwise moment. And then for our weights now, those will be our clockwise moments. So first and foremost, with our weights, we need to work out we need to make it perpendicular to that rod first. So to make it perpendicular, well, if we make it perpendicular, if I zoom in here, if we make it perpendicular, then it would be in this direction, okay? That would be perpendicular to the rod. And if we look here, like this and this, that's a right angle, right? So we know that this is a right angle here. Therefore, we know that if we have sine theta there, we know that this value here must be the cos theta, okay? It must be whatever theta is. And therefore, exactly the same with the 2mg, it'll be the exact same. Make that, if we make it perpendicular to the rod, we would also just get a cos theta here. We can look at that, and that is just corresponding angles. they would be the same. So therefore, we know that both of them would be cos theta, which makes perfect sense in that scenario. Therefore, if I go back to this question, for our anti-clockwise moments, no, our clockwise moments would be an mg cos theta, okay, cos theta, and then the distance of that, well, that's just, well, for the mg, that's just a away, so times a, and then we get a 2mg cos theta, and that is 1.5 away, so that would be times by 1.5a. Okay, so then that would be, what we can do now, actually, we can cancel out the a's, because they all have a's in them, so we can cancel out the a's, and then we will just be left with a 2t is equal to an mg cosine theta plus, so mg cosine theta plus a 2mg cosine theta times a 1.5. So therefore that would be a plus 3 mg cosine theta. And therefore a 2t equals a 4 mg cosine theta. And then for our t value, which divide by 2, we get a 2 mg cosine theta. So for part C, we're told that given that cosine theta is equal to 3/5, we show the magnitude of the vertical force exerted by the ground on the rudder A is 57 mg/25. So what they're saying is if it's the magnitude of the vertical force exerted on the ground at the rudder A, what they're actually saying is for us to work out the normal reaction. So work out this on newtons here. So that's what we need to work out. And from our previous question, we know that t is equal to a 2 mg cosine theta. So using that, we can resolve vertically now. And if we resolve vertically, so resolve vertically, what would that be? Well, that would be a r. And now we have to work out this t value, okay? This t value, because we know that t does have a vertical component, but we don't know what that is yet. So if I draw like a dotted line here, then we need to work out what that value would be for t, okay? That's what we need to figure out. Now, how can we figure that out? There's loads of ways you can figure it out. What I would say is, with t, it's going to have a vertical component. It will also have a horizontal component as well, which makes up the 90 degrees, okay? So therefore, let me make that a bit more straight. Okay. So therefore, we have these two angles here we need to work out. Now, to work out these two angles, well, what you can think of is, if I zoom in, is that this cosine of this theta here, this cosine theta value, if you look at it, that is at the angle to the horizontal, right? Therefore, if I draw that here, this angle here must also be a theta. Okay, so this angle will also be just a theta, or you can think of it as cosine theta. And therefore, if I just draw an S here, that will be a sine theta. Okay, therefore, because we know that there's a right angle there, so we know that if this is theta, that will be a sine theta. Therefore, this will be a theta value here, or a cosine theta. Okay, so now so for this type of question, we know that with t, we know that t, its vertical component will be cosine theta, its horizontal will be a sine theta. Okay, so now that we worked that out, therefore that would be r plus a t cosine theta, okay, because we want the vertical component, and that would equal our mg plus our 2mg, okay, just our downwards weight forces. So that's it. So now we know that r plus t cosine theta is equal to 3mg. Now they also tell us in the question that cosine theta is equal to 3/5. So you know that's equal to 3/5. We also know that t is equal to 2mg cosine theta. So we can rewrite this as r plus the t, which is 2mg cosine theta, and then times another cosine theta is equal to 3mg. And then we can just put in our values. So we have r plus 2mg times by a 3/5, and then another 3/5, or 3/5 squared. And then we can just work this out, okay? So if you work this out, if you do 2 times 3 over 5 times by 3 over 5, then you will get a r plus a 2 times 3 over 5 is a 6 over 5. Then a 6 over 5 times a 3 over 5, that would be an 18 over 25 mg. Okay, and that's equal to a 3 mg. And now that means that r is equal to a 3 mg minus 18 over 25 mg, which means that our r value, that is, if we make 3 a fraction over 25, that would be 75 over 25 mg minus 18 over 25 mg, which equals what we want, which is 57 over 25 mg. So for part D, we're told that the coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, show that mu is equal to 8 over 19. Okay, so this one again, I've got my graph drawn here. Now for this one, we can actually change some of our values now, because we know that it's R newtons. We know that that is going to be a 57 over 25 mg newtons, so we can just change that to that. Our T, we can also change, I'll leave that as that for now. And what we need to do is work out mu. Okay, so what do we know about mu? Well, we know that mu, or the friction, is equal to mu R. Okay, so that is mu times the normal reaction at A. And in this case, we know what R is, so we know that F is equal to mu times by the 57 over 25 mg. Okay, so really all we need to do is work out what our frictional force is. And once we know what our frictional force is, we can just do our frictional force divided by our normal reaction, which is the 57 over 25 mg, and that should hopefully give us 8 over 19. So how do we work out our frictional force? Well, as I stated in part A, we know because we're in equilibrium, we know that the frictional force has to be going to the right to balance out the tension. So therefore, we can just resolve horizontally, okay? So if we resolve horizontally, that would be an F, and that would equal T. Remember this time T, if we look here, the horizontal component of T would be here, okay? And that would be this S I've drawn here from the previous question. That's a sine theta. So therefore, we know that it's just going to be F is equal to T sine theta, okay? So that is that one. So now, what do we know about this? Well, we know that our F value, that is equal to because T was 2 mg cosine theta. So it's 2 mg cosine theta then times by a sine theta. Now, we know from the question, earlier question I believe from B, we are told that cosine theta is equal to 3 over 5. Therefore, if we draw like a right angle triangle, okay, draw a right angle triangle here, well, if we know that cosine theta is 3 over 5, then we know that the adjacent would be 3, the hypotenuse would be 5, therefore the opposite would be 4. So therefore, our sine theta is equal to 4 over 5. And we know everything now, so we can work out what our F value is. So F is equal to 2 mg times by cosine theta, which is 3 over 5, times by a sine theta, which is 4 over 5. And if we work that out, well, we get a 2 times 4 over 5, that is a 6 over 5, and then a 6 over 5 times by a 4 over 5 is a 24 over 25 mg. So now we've worked out our frictional force is 24 over 25 mg. Therefore, if we go back to the equation, F is equal to mu R, okay, we know that F is 24 over 25 mg. That is equal to our mu, and our reaction, that was 57 over 25 mg. So therefore, mu is just going to be a 24 over 25 mg divided by a 57 over 25 mg, and that is the same as saying 24 over 25 mg times by a 28, that's a 25, my handwriting's bad, a 25 over a 57 mg. Now the mg is at the bottom because we just flipped everything. And now if we just cancel everything out, mg's cancel out, and the 25s also cancel out. So we are left with a 24 over a 57, and that simplifies down. Both are multiples of 3. That simplifies down to 8 over 19. Okay, so for this one, we have a golf ball is at rest at the point A on horizontal ground. The ball is hit and this moves an angle alpha to the ground. The ball first hits the ground at the point B, where AB is 120 meters. The motion of the ball is modeled as that of a particle moving freely under gravity, and the initial speed is u meters per second. We can show that u squared times sine alpha cosine alpha is equal to 588. Okay. These type of questions, we know that it's going to be suvat. Okay, we're going to use suvat, but we're going to have a horizontal suvat and a vertical suvat. So first thing first, let's formulate those type of equations. Okay, so I've drawn a little diagram here, and with this type of question, okay, let's start with the horizontal component first. Okay, so we'll start with the horizontal component, and if we start with that, then what do we need to do? Well, let's work out our suvat equations first. So horizontally, we're going to have a S value. Now, horizontally, we can see that if we have something and it travels, it goes from A to B, they tell us in the question that AB is 120. So therefore, S is just 120. For this, we have U as well. We know what U is. They tell us that it travels at U, like capital U meters per second. So therefore, if we're looking at horizontal, that would be a U, a cosine alpha. Okay, we're dealing with horizontal, so in this case, horizontal would always just be that cosine alpha because it moves an angle alpha. Now we don't have to worry about V because remember when we're dealing with horizontal components, horizontal stuff like this, the horizontal component, the acceleration is always 0, so it's going to just travel at the same, effectively the same speed the whole way through. So we don't need to worry about V. And we know A is 0 because it's going to be at constant speed, so we don't need to worry about our A either. And we have a value T. Okay, that's our horizontal component. Now, what we're going to think about this question is with these type of questions. Okay, when we are solving them, we know that the time it takes to travel from A to B, right? The time it takes to hit the ground from A to B, the time we get in the horizontal component will be exactly the same time we get in the vertical component. So really with these questions, what you want to do is you want to try and get an expression for T, because that T value should equal the same T value in the vertical component. So let's just rearrange this equation. So we know that the normal suvat equation, if we have values like this, it would be something like S is equal to UT plus a half AT squared. Now remember for this type of question, that obviously, because when we're traveling horizontally, it's at a constant speed, so A would be 0. Therefore, we can rewrite this as S is equal to UT. And therefore, for this type of question, if we do that, we would get a 120, that's S. U is a capital U cosine alpha, and that would just be times by T, okay? And if we rearrange that, then that would just be T is equal to 120 over a U cosine alpha. So now that is our horizontal component. We know that when the particle, when it travels, when it hits the ground, it will have a time of 120 over U cosine alpha. Now let's do the vertical component of this golf ball. Okay, so the vertical component. Now with vertical, make sure that with vertical, you need to specify what direction you're going in because that will change some of your values, whether they're going to be positive or negative. So we do the vertical component. Well, vertical component, let's do the suvat for that. So suvat would be that S would equal 0. Okay, our displacement would be 0, and that always makes sense because you think about it. The golf ball, it starts at 8, it goes up in the air, it goes up, and it goes straight back down. The displacement would just be 0, okay? Because let's say you go up, you go up, and then you're going all the way back down, you'll end up at exactly the same point. So displacement is just 0. So we know S is 0. We know U, because we're dealing with the vertical, we know U is going to be a capital U, and this one will be a sine alpha, okay? Our v, we don't know our v value. We can leave that as v. Now our a, this is the key one. Our a acceleration, because we're going vertically, we know that it's acceleration due to gravity. It would be a minus 9.8. And the reason why it would be a minus 9.8 is, remember that we've specified that up is our positive direction. Therefore, if we specify that up is our positive direction, that must mean that it will have a minus 9.8. Because if we're specifying that going up is the positive direction, then our 9.8 must be negative, which makes sense, because if you're traveling upwards, our acceleration is definitely going to be decelerating if it's going up, because it will decelerate as it's going up. Eventually, it'll get to the maximum height, and then it will start to accelerate as it's going back down. So it makes sense. So our a is a minus 9.8, and for our t value, again, it's just t. But we want to work out that t value, okay? So if we work out that t value, we can use the equation like in the previous question. S is equal to ut plus a half at squared. So that would be a 0 is equal to a u sine alpha t plus a half times a minus 9.8 times a t squared. And then that would give me a u sine alpha t minus a 4.9 t squared, and that is equal to 0. So if you think about this, if we were to factorize now, we'd get a t, then in brackets we'd get a u sine alpha minus a 4.9 t, and that is equal to 0. Therefore, we know that t is 0. That's one of our values for t, and that makes sense. Because you think about it, like we will be at t is equal 0. We're just starting, okay? So it makes sense that that the ball will be at, it'll be on the ground, or will be at point A or point B at that t equals 0. That makes sense. It's the other value we want to work out, because that's after we've hit the golf ball, it arrives back at that same displacement, right? So we know that with t equals 0, the displacement is, yes, 0. And we know that once we get this next value for t, that will be once it gets to b. So therefore, we know that a u sine alpha minus 4.9t is equal to 0. Therefore, if we now work this out for t, we would get a u sine alpha is equal to a 4.9t. Therefore, t is equal to a u sine alpha over a 4.9. So now we've worked out that for our vertical component, when that golf ball travels to b, its time is u sine alpha over 4.9. And we know that with the horizontal component, when the golf ball travels to b, its time is 120 over u cosine alpha. Those values are equal to each other because the time is going to be the exact same. It doesn't matter if we travel horizontally or vertically. If once that golf ball travels from A to B, it should have the exact same time. Therefore, we need to make these values of t equal to each other, okay? So I write the other value here, which was t is equal to 120 over u cosine alpha. These values must be equal to each other. Therefore, we have that u sine alpha over 4.9 is equal to 120 over u cosine alpha. And therefore, once they're equal, we can just cross multiply. Therefore, we get a u sine alpha, and that would be times by a u cos alpha is equal to 120 times by 4.9. If you work that out, that will give us a u squared sine alpha cos alpha, and then 120 times by 4.9 is a 588. So for the next question, we're told that the ball reaches a maximum height of 10 meters above the ground. We ensure that u squared is equal to 1960. So if I do this on this question here, well, again, we're going to look at the vertical component, okay? And we're going to consider the upwards being the positive direction. So if we look at it this way, well, we're told now that we reach a maximum height of 10 meters, okay? So therefore, in this case, our displacement would be 10. Our u would stay the exact same. So our u would still be a u sine alpha. But now because we're reaching a maximum height of 10 meters, right? Therefore, that means that at that maximum height of 10 meters, for us to get to that maximum, we're traveling. To get the maximum height, the golf ball must have a velocity of 0 because it's going to travel. It's going to be decelerating. It's going to get to 0, and then it will start to come back down. So we also know that v is equal to 0. And we have a again as minus 9.8. And yeah, we don't know our t value again because our t value has changed. We don't know what the t value is at the maximum height. So we can just leave it like this for now. So using the information we've got, we know that we need to get some form of expression for u. And we have an s value, we have a v value, and we have an a value. So therefore, we would use this Suva equation of v squared is equal to u squared plus 2as. So if we use that equation, therefore we get a 0 is equal to a u sine alpha squared. So that would be a u squared sine squared alpha plus a 2 times a minus 9.8 times a 10. That gives me a 0 is equal to a u squared sine squared alpha. And that would be a 2 times a minus 9.8, which is a minus 19.6 times 10, which is a minus 196. Okay, therefore we know that u squared sine squared alpha is equal to 196. So, and we also know from the previous question that a u squared sine alpha cosine alpha is equal to a 588. Okay, so we've got this equation here and we've got this equation here. Now we want to show in the question, we want to show that u squared is equal to 1960. So what we can do for this question is we can just divide the 2 by the, no, we can divide the 1 by the 2. Okay, let's divide the 1 by the 2. So let's, because if we do that, we should just end up with just a sine alpha. So if we do that, we get a u squared sine squared alpha, and that would be over the u squared sine alpha cosine alpha, and that is equal to a 196 over a 588. So the u squareds cancel out. That signs, just one of the signs cancel out with the sine alpha. And actually, this all cancels out as well. This will be a 1 and this will be a 3. So what are we left with? We are left with a sine alpha over a cosine alpha is equal to a 1 over 3. Therefore, that means that a tan alpha is equal to a 1 over 3. Okay? So now, we don't actually want to work out what the alpha value is. We can, but actually, if we look here, right, this is what I'm looking at here. This already has the u squared and sine squared alpha, right? If we can get a value for sine alpha, then we can just plug in that value into this equation here, and we can work out and we can hopefully get an answer. Or we can also work out what our cosine alpha value is along with our sine alpha and plug it into this value. Either one will give you the answer. So now that we have the tan alpha is equal to a 1 over 3, what we can do is if we draw a right angle triangle here, okay, therefore we know that opposite over adjacent, we know that it'll be 1 here and it'll be a 3 here. And then therefore what that means, well, our 3 squared plus 1 squared all square rooted, that will give me a root 10. Therefore we know that a sine alpha would equal a 1 over root 10, that's opposite over hypotenuse, and a cosine alpha would equal a 3 over root 10. Now that we know that, we can actually use those values now to just plug them into any one of these equations, either this one or this one. It doesn't really matter. I would say the easiest one is definitely probably this one over here because we just have the sine alpha. But you can also plug it into this one too. Both will give you the same answer. So I'm going to plug it into equation 1. Okay, so equation 1 was the u squared sine squared alpha is equal to 196. Therefore, a u squared, that would be times a 1 over root 10, because sine alpha is 1 over root 10. And it will be all of that squared, okay? And that's equal to 196. Therefore, u squared is equal to a 1 over root 10 squared is just going to be a 1 over 10. So we just get this. And then simply, if we divide by the 1 over 10, bring the 1 over 10 to the side, we will just be left with a u squared is equal to a 1960. Okay, question C. Okay, so we're told that in the refinement of the model, the effect of air resistance is included. Okay, and the motion of the ball from A to B is now modeled as that of a particle whose initial speed is v. Okay, so using this refined model is used to calculate a value for v, which is greater, u or v. So with this other question, okay, we know that v is, I guess, it's that initial speed, but it's got air resistance now. So we need to think about whether is v going to be bigger with air resistance, or is u going to be bigger, and that's the speed without air resistance. Well, you think about it, if something is traveling okay, and it has air resistance in it, and it's still going in the same course or direction, well then the v has to be bigger, the speed with the air resistance, because it has to overcome the air resistance in order to get to that same motion. Therefore, if I write it here with v, with c, therefore v is greater because it has to travel at a faster speed to overcome the air resistance, right? It has to travel further. The air resistance is like going against it, right? It has to travel at a higher speed to get to that same motion. So v is greater because it has to overcome the air resistance. So that would be question C. And then for part D, we need to state one further refinement to the model, which will make the model more realistic. Loads of things you can say. I would say that you can probably say something like the ball, for example, like the shape of the ball, dimensions need to be more included. But another thing too is with these type of questions, we consider it having, having just a constant acceleration all the time. But the problem with that is, of course, that if something is traveling through the air like that, it's not really going to have a constant acceleration all the time. It's going to have more of a variable acceleration. So what I would put is something like to make the model more realistic, it should have variable accelerations, something like that. Okay, and yeah, that would be this paper done. Yeah, I hope you enjoyed this. For my next video, I'll make another mechanics video, most likely 2024. So yeah, I hope you enjoyed this video, and I hope to see you on the next.